My dear cadets, welcome to you all at the virtual arena of Borishal Cadet College. I am Joydev Mondol, lecturer, Department of Mathematics, Borishal Cadet College. Dear cadets, due to coronavirus, you did not able to come to your college. That's why I am here to take a class virtually. At the very beginning of my class, I want to say, wash hands with water and soap or sanitizer at least 20 seconds. Avoid contact with sick people. Don't touch eyes, nose, or mouth with unwashed hands. Don't eat raw food. Thoroughly cook meat and eggs. Avoid contact with animals and animal product. Dear cadets, what can you see here? Yes, this is a number line. You know, with the help of this number line, we can represent all the real number. Again, what you can see here? Here, -5 greater than or equal -3. Is it true or false? This is the question. So, this is not equal. So, which is not equal is called unequal. So, today we will talk about the real number and the inequality. So, my today's topic is real number and inequality. First of all, learning outcomes. Dear cadets, at the end of this class, you will be able to solve inequality with one variable, solve inequality with absolute value, answer MCQ questions. So let us start the problem. Prove that if AB belongs to R, then modulus of A minus B is greater than modulus of A minus modulus of B. Let's start proof. We know that for any real number AB less than modulus of AB, or AB less than, modulus of AB equal to modulus of A into modulus of B. Then multiplying this inequality by -2, we get -2 AB. Here is less than. Since -2 less than 0, so that sign will be changed. It will be greater than or equal into greater than or equal -2 modulus of A to modulus of B. Then again adding modulus of A square plus B square on both sides, we get modulus of A square minus 2AB plus modulus of B square is greater than or equal modulus of A square minus 2 into modulus of A into modulus of B plus modulus of B square. Cadets, modulus of A square, that means A square minus modulus of A into modulus of B plus modulus of B square, that means B square. And here we get the formula A minus B whole square, that is modulus of A minus modulus of B whole square. So cadet, finally we get A square minus 2AB plus B square, that is A minus B whole square. This greater than or equal modulus of mod of A minus mod of B whole square. So finally what we can get here? Modulus of A minus B square, because we know that A minus B whole square equal to modulus of A minus B whole square. This equal to modulus of A minus B whole square greater than equal modulus of A minus modulus of B whole square. So dear cadets, finally we get modulus of A minus B greater than or equal modulus of A minus modulus of B. So we have already proved. Dear cadets, I hope you have understood this. Cadets, now we will solve another problem. The problem is rewrite the inequality modulus of x minus 4 less than 2 without using absolute value sign. So let us start. Solution. Given that modulus of x minus 4 less than 2. So what we can do? We can do this minus 2 less than x minus 4 less than 2. How? Cadets, you know, if modulus of x less than alpha, then we can write minus alpha less than x less than alpha. Applying that formula, here we get minus 2 less than x minus 4 less than 2. Then adding 4 on each side, we get minus 2 plus 4, x minus 4 plus 4, and 2 plus 4. So finally, we get 2 less than x less than 6. So this on is our required answer. Very easy, boys. I am repeating again what I have done. First of all, I have written the given portion, this one, then applying the property of absolute value sign, then adding each side by 4, we get the required result. Okay, boys. The next problem is rewrite the inequality minus 8 less than equal to x less than equal to 2 using absolute value sign. So start. Given that minus 8 less than equal to x less than equal to 2. In our previous question, we have expressed the absolute value signed problem in the term of without absolute value sign. But here we have to express this inequality with the help of absolute value sign. So first of all, we see the average of minus 8 and 2, that is minus 8 plus 2 divided by 2, that is minus 3. So in every side of this inequality, the inverse of minus 3, that is 3, will be added. So do it. Minus 8 plus 3 less than equal to x plus 3, that is less than equal to 2 plus 3. Finally, we get minus 5 less than equal to x plus 3 less than or equal 5. Again, applying the formula property of real absolute value sign, we get modulus of x plus 3 less than equal to 5. Now another problem. Find the infimum and supremum of s equal to the set of all r x belongs to R such that 5x square minus 16x plus 3 less than 0. So let us start. Here given that S equal to the set of all x belongs to R such that 5x square minus 6x plus 3 less than 0. So we can write the statement, that is the expression 5x square minus 16x plus 3, this equal to 5x minus 1 into x minus 3. It is very easy, just applying the factorization. Now we have the inequality 5x minus 1 into x minus 3 less than 0. If we take common 5 from the first one, we get 5 into x minus 1 by 5 into x minus 3 less than 0. If we divide both sides by 5, we get x minus 1 by 5 into x minus 3 less than 0. In the above inequality, we see x into x minus 5 into x minus 3, this one less than 0. So the above inequality is true if The expression x minus 1 by 5 and x minus 3 are on positive and on negative. If it not, that is if both are positive, then the inequality will be false. If both are negative, then that will be greater than 0. In that case, the inequality also will be false. So we have to get one expression is positive and another expression is negative. So we want to see a number line. In this number line, we see that if the value of x less than 1 by 5, then both of these expression are negative. If the value of x is less greater than 1 by 5 but less than 3, then one is positive, another is negative. If this value of x is greater than 3, then both of these expression are greater than 0. That is both are positive. So what will be our required interval? That is minus 1 by 5, 1 by 5 less than x less than 3. So we see S equal to the set of all x belongs to R such that 1 by 5 less than x less than 3. So what is the infimum of this set? We know that the lower bound of the set is, and the greatest lower bound is called the infimum. So here we see that all the values of the set S are greater than 1 by 5, and this 1 by 5 is the greatest value of all among the all lower bound of S. So 1 by 5 is the infimum. Again, what is the supremum of S? Here we see that all the values of set S are less than 3, and 3 is the least value among the all upper bound of set S. That's why 3 is called the, here 3 is the supremum of S, that is sup S. Now we have to prove another thing. We have given that if modulus of x minus 1 less than 1 by 10, then we have to show that modulus of x square minus 1 less than 21 divided by 100. This is very much important question for you. So let us start. First of all, we see we have given that modulus of x minus 1 less than 1 by 10. So by the property of absolute value sign, we can write minus 1 by 10 less than x minus 1 less than 1 by 10. Then adding on each side, we get minus 1 by 10 plus 1, x minus 1 plus 1 less than 1 by 10 plus 1. Then what we can get? Calculating this, we get minus 1 plus 10 divided by 10 less than x less than 1 plus 10 divided by 10. That is minus 1 plus 10, that is 9 divided by 10 less than x less than 1 plus 10. This 1 plus 10, that is 11 divided by 10. So now what we will do? In the left hand side, we have modulus of x square minus 1. So now squaring on each side of this inequality, we get 80 on 9 square, that is 81 divided by 10 square, that is 100 less than x square less than 11 square, that is 1 to 1 121, and 10 square, that is 100. Now subtracting on from each side, that is 81 divided by 100 minus 1 less than x square minus 1 less than 121 divided by 100 minus 1. Then calculating, this is the LCM, that's why 81 minus 100 less than x square minus 1 less than 121 minus 100 divided by 100. Then calculating this one, we get minus 19 divided by 100 less than x square minus 1 minus 21 divided by 100. Now cadets, you see minus 21 divided by 100 less than minus 19 divided by 100. If you let this one is A and this one is B, then and this one is C. If B is less than C and A is less than B, then A must be less than C. Applying that formula, we get minus 21 divided by 100 less than x square minus 1 less than 21 divided by 100. So again applying the property of absolute value sign, that is if minus alpha less than x less than alpha, then modulus of x less than alpha. Applying that formula, we finally write modulus of x square minus 1 less than 21 divided by 100. So proof. Dear cadets, this problem is very much important for you. You will practice this problem more and more. Another problem. If modulus of x minus 1 less than half, then show that modulus of x cube minus 1 less than 19 by 8. So let's start. Given that modulus of x minus 1 less than half. So applying the absolute value property, we can write minus half less than x minus 1 less than half. Then adding on each side of this inequality, we get minus half plus 1 less than x less than half plus 1. Then calculating this, we get half less than x less than 3 by 2. In our proof section, we have to prove modulus of x cube minus 1. So I have applied cubed on each term, that is 1 by 2 whole cube, that is 1 by 8, that is, you know that 2 cube equal to 8, and cube of 3 equal to 27, and cube of 2 equal to 8. That's why I have got 1 by 8 less than x cube less than 27 divided by 8. Then subtracting on from each side, we get 1 by 8 minus 1 less than x cube minus 1 less than 27 divided by 8 minus 1. So what is the last answer? We get, calculating this one, 1 minus 8 divided by 8 minus x cube minus 1 less than 27 divided by 8, 27 minus 8 divided by 8. Then finally calculating, we get minus 7 divided by 8 less than x cube minus 1 less than 19 divided by 8. So in our last problem, we have already solved. If this happened, then we can write minus 19 divided by 8. How we can write? We see it. Since 19 divided by 8 less than minus 7 divided by 8 and minus 19 divided by 8 is less than x cube minus 1. So since this happened, finally we can write this. So applying the property of absolute value sign, that is if minus alpha less than x less than alpha, we can write modulus of x less than alpha. So finally we get modulus of x cube minus 1 less than alpha. Dear cadets, these questions are very much important for you. I hope all of you will practice this several times. Now I will discuss some MCQ question. These MCQ questions are important not only for the board exam but also for the admission test. The first question is, solution of x square minus 4 is. This is the question of session 9-10 of a university, Jahangirnagar University. What is given? Minus 2 less than x less than 2. Number A. Number B, x greater than 2. Number C, x less than minus 2. And number D, none of this. So we see the explanation. We have given that x square minus 4 less than 4. So what we can write, modulus of x square less than 4. So x must be less than 2. So what we can write, minus 2 less than x less than 2. So the required solution is minus 2 less than x less than 2. So which one will be our answer? This one, number A. So we will mark this one is our answer. Okay. Now the next one. Which of the following is the irrational number? Number A 2.362, number B 2.1212, and it is the recurring number, and number C 2.5264, number D. Which one is our desired result? So we see the explanation again. The number in option C has digit after decimal point which are not repeating and not terminating, so it is an irrational number. You have understood? So the result will be number C. Now the next one. If modulus of pi minus 2 is expressed without absolute value sign, then which one of this is correct? Number A, pi minus 2, number B, 2 minus pi, number C, pi, number D, minus 2. We want to see the explanation. Minus pi minus 2, you know the value of pi is 3.14. Putting that value and calculating, we get the result 1.14, which is greater than 0. Again, you know, if x greater than 0, then modulus of x equal to x. So the result, that is modulus of pi minus 2, here pi minus 2 is greater than 0, so the result will be pi minus 2, which is given in number A. So the result is number A. Next one. The solution of 3x plus 2 less than 7 is. This question was set in Russia University several times, so you want to see the explanation again. First of all, here we see that this is given. So minus 7 less than 3x plus 2 minus 7 less than 7. We can write it with the help of absolute values sign property. Then subtracting 2 from each side, we get minus 9 less than 3x less than 5. So finally, dividing each term by 3, we get minus 3 less than x less than 5 by 3. So what is the solution? Solution is minus 3 less than x less than 5 by 3. So we see that number A, number B, number C, no one is just like the minus 3 less than x less than 5 by 3. So the answer will be none of this. Now, dear cadets, I have tried to discuss everything related to the real number and inequality. If you feel any problem, then you must ask me in your discussion section. Now it is time to take home task. Your homework is f of x equal to 5x minus 7, g of x equal to 2x plus 1. Number A, evaluate 13 plus modulus of minus 1 minus 4 minus 3 minus modulus of minus 8. Then number B, solving the inequality 1 by f of modulus of x greater than 2, show the solution set in the number line. Number C, with the help of number line, solve x g of x divided by f of x less than 0. Now, dear cadets, at the very last time of my class, again, I want to say you what you need to do for fighting against corona pandemic. First of all, wash your hands, use a tissue for coughs, avoid touching your face. Thanks a lot.